Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Today I would like to give a view about our topics today, which is nomenclature of chemical compounds. This topic is introduced by Dr. Nolia and I will explain it as sharp as possible. So, nomenclature of chemical compounds, which are also naming compounds, are correctly is effective through communication of chemistry. And today, I will guide you through it step by step. In this topic, there were three main topics, subtopics, which are ionic compounds, covalent compounds or molecular compounds, and also organic compounds. And I would like to give example and share a helpful tips to make this easy to understand. And before that, I will give an introduction by myself and my college also. So, let's dive in and let's starting with ionic compounds. Alright, so ionic compounds got three naming ions, which are metal ions, monoatomic ion, and polyatomic ions. Ionic compounds are made of metals and non-metals. To name them, you start by naming the metals, followed by non-metal, which the compound will end by the word IDE. For example, like sodium chloride, or in chemistry name is NaCl. You see, sodium is metal and chloride is non-metal, and both of them is separated by various type of groups, and because of it, it will end at IDE at the end of the word sodium, and that's why I took sodium chloride as a good example to show that how this naming works. Okay, I would like to add another information about metal ions and polyatomic ions. First of all, when it comes to metal ions, it included two metals which are maintained the name of the metal. That's like it will add ion at the end of the compound names. So I will take an example like Na or sodium ion. It will become ion at the end because, like I said, it just included metals and not non-metals. Just same as like magnesium ions, Mg, and also calcium ions. And for polyatomic ions, it is a covalent bond set of two or more atoms, just as you can see in the picture below. It says that all of a metal complex, and I will take an example. When it becomes to BaSO4, you can see two different groups in one compound. Like Ba is barium, and barium is located at group number 2. So basically, there were metals, and to achieve of that, they have to donate their electrons and it will become positive, just like positive 2. So you can put Ba2 positive charge. So how about SO4, sulfate and oxygen? Okay, sulfate and oxygen both of them in the same group, which are group number 16. And when it becomes like that, it is not metals, and they have to achieve of that by accepting 2 more electrons, so it will become negative charge. You got it?
Now, I would like to talk about cation and anion. Cation. The name of monoatomic cation always start with the name of the metal, sometimes followed by a Roman numeral to indicate the charge of the ion. Next, anion. The anion is named by taking the elemental name, removing the ending and adding the negative IPE. For example, hydrogen. If an anion, it can be like hydride. Next, naming transition metal ionic compound. Use the total charge on the non-metal or polyatomic ion. Find the charge on the transition metal. After the name for the metal, write its charge as a Roman numeral in parentheses. Now, if the metal has multiple oxidation states, we need to indicate its charge using Roman numerals. For example, FeCl2 is ion 2 chloride, while FeCl3 is ion 3 chloride, and Cr2S3. It can be like chromium 3 sulfide. Another example is CuO, which is copper 2 oxide. Here, copper has a positive 2 charge. Got it? Great. Now, let's move on to covalent compound.
Okay, now I will explain about covalent compound. Covalent compounds are formed between two nonmetals. Unlike ionic compounds, we use prefixes to show the number of atoms in each element. For the naming molecular compounds, the terms are nonmetals or nonmetals plus metalloids. The other term is last element name ends in IDE. Okay. For example, Hi, the name is hydrogen iodide. For another example, NF3, the name is nitrogen trifluoride. Another example is SO2, the name is sulfur dioxide. For the naming molecular compounds, we have 10 names for elements, such as for one element we use mono, for two elements we use di, for three we use tri, for four we use tetra, for five we use penta, for six we use hexa, for seven we use hepta, for 8 we use octa,
For 9 we use nona, and for 10 we use deca. For instance, CO2 is called carbon dioxide. The di shows there are 2 oxygen atoms. Another example is N2O4, which is dinitrogen tetroxide. Easy, right? Let's move on to the final section, which is organic compounds.
I'm going to be talking about naming hydroacids. Now I'm going to be talking about naming hydroacids. It includes hydro, halogen name, and also IC. After that, acids which do not contain oxygen are named by adding the hydro prefix to the root name of the element, followed by IC suffix. The formula are HF. As for the molecular name is hydrogen fluoride. And as for the acid name, it's hydrofluoric acid. That's only one of the example. The next one is HCl, which is hydrogen chloride, and the acid name is hydrochloric acid.
Next, I'm going to be talking about naming oxoacids. Oxoacid is an acid that contains hydrogen, oxygen, and other elements. The naming rule of oxoacids are: it starts with the base name of the central atom, add a suffix depending on the number of oxygen atoms. As an example, IC acid is the acid contains more oxygen. Os acid if it contains fewer oxygen atoms. Here's a few examples. H2SO4 is sulfuric acid because it has more oxygen. H2SO3 is sulfurous acid because it has fewer oxygen atoms. If there are even more variation in oxygen, prefixes like per and hydro are used. Next, I'm also going to be talking about naming oxoacids and oxoanions. When all the H ions are removed from the IC acid, the anion's name ends with 8. Next, when all the H ions are removed from the OS acid, the anion's name ends with 8. The names of anions in which one or more but not all the hydrogen ions have been removed must indicate the number of H ions present. I'm going to be giving a few examples. As for anion, ClO4 is perchlorate, ClO3 is chlorate, ClO2 is chloride, ClO is hypochlorite. As for acid, HClO4 is perchloric acid, HClO3 is chloric acid, HClO2 is chlorous acid, HClO is hypochlorous acid. In summary, now we've learned about naming ions, cation and anion, naming transition metal, ionic compound, naming molecular compounds, naming hydroacids, and naming oxoacids and oxoanions. By following these rules, chemists can ensure clear and consistent communication worldwide. With practice, the naming process becomes a straightforward and essential skill in chemistry. That's all from us. Thank you.